Professor Holm,
Yes,
are you going to go over the quiz?
I was just about to do it.
Oh,
That's my normal protocol.
I actually have a question. Can you go over later on how to do the sign of charge, the sign charge?
Okay, well, I'm going over the quiz now.
Right, thank you.
Okay, so it should be recording also. So f of x equals x cubed minus 3x squared. So take the derivative, 3x squared minus 6x. That factors into 3x times x minus 2. Yeah, I messed up. What else is new? All right, so I set the derivative equal to 0. So what numbers make this expression 0? Well, 0 and 2. All right, and then I plug in to find the corresponding y values. So f of 0 is easy. Plug in 0, 0, minus 0 is 0. So 0, 0. Plug in 2. 2 cubed is 8. Minus 3 times 2 squared, that's 3 times 4. So 8 minus 12 is negative 4. Okay, so my critical points are 0, 0, 2, negative 4. And now I determine, do I have a maximum, do I have a minimum, or neither? Okay, so that's why I do a sign chart. Okay, so on my number line, I laid down the values for which the derivative came out to be 0. That was 0 and 2. Okay, all right, so one more time, here's the expression for the derivative. You can tell when you plug in 0, you get 0. 3 times 0 times whatever is 0. And you can tell when you plug in 2, put a 2 here and a 2 here, 2 minus 2 is 0, so 0 times all that is 0. Okay, those are the only two numbers for which I get 0, so nowhere else do I get 0. That means if it's not 0, it's either positive or negative. Okay, so I need to determine, is it positive or negative? That'll tell me if the function is increasing or decreasing. Okay, so I pick a number over here, like negative 1. I pick a number here, like 1. I pick a number here, like 3. Okay, I should actually draw a separation here. Yeah, that's a little bit better, separation. All right, so I plug into the derivative, negative 1. I don't need the exact value. I just need the sign. So 3 times negative 1 is negative. Negative 1 minus 2 is a negative. Negative times a negative is positive. So I put a plus on this region over here. Then I plug in 1. 3 times 1, positive. 1 minus 2, negative. Positive times a negative is negative. So the middle region, put a minus sign. Then when you plug in 3, everything is positive. Put a 3. 3 times 3, positive. 3 minus 2, positive. Positive times positive is positive. So positive. All right? A positive derivative means the function is increasing. Think back to your algebra 1. In algebra 1, you had a positive slope. That means the line looks something like that. Okay? So that means in general, it's going like that. The function's increasing. In algebra 1, if you had a negative slope, that means it falls. The graph is decreasing. It's going down. The roller coaster is going down as I move from left to right, decreasing. All right, now I can determine maximum and minimum points. Okay, at x equals 0, the graph increases and then decreases. Think of a ride, a roller coaster ride, or you're walking or you're driving. You go up, then you go down. You reach the maximum. So I have a maximum at 0, 0. Look at x equals 2. You decrease, and then you increase. So if on your ride, roller coaster ride, or your car, or you're walking, you go down, and then you go up. So you bottomed out. You reach the minimum value. So I have a maximum at 0, 0, a minimum at 2, negative 4. You want to see a quick graph, up, down, up. Increasing until I reach 0, and then it starts to decrease, and it increases again. So this is a quickie graph of what it looks like. So I have a maximum at 0, 0, a minimum at 2, negative 4. And that's the way it works. Okay, so that was the quiz. And the next section, we're going to build on that concept. So we're still going to keep everything we have here, but we're going to do more. Okay, I mentioned sort of in passing the horizontal point of inflection last time. We're going to do all points of inflection now, whatever that means. Okay, so that's it for the quiz. And let me get started with the new stuff. Okay, so 10.2 is where we're at. Look at our mini calendar, do one section a day, 10.2, 3, 4, 11, 1, 11, 2. So our fourth test looks like on November the 19th. That's the Thursday just before Thanksgiving. Okay, so if I do the one section a day, 10.1, 10.2, 10.3, 10.4, 11.1, 11.2. Okay. Now 10.2, there's only 8 problems. Okay, I'm going to end up doing 3 of them. Okay. And then if I finish early, I'll let you ask questions about 10.2 or 10.1. It's up to you. All right, so this is our progression. Okay, so let me start 10.2. 15 to 22 is the homework problems. So 10.2, page 643, something called concavity and points of inflection. Okay. We talked a little bit last time about horizontal points of inflection. Now we're going to talk about all points of inflection. Okay. So concavity, what is this concavity stuff? Okay, on page 644. Okay, this is describing how the graph curves. Okay, we're going to define something called concave up and concave down. I will abbreviate with CU and CD. Concave up, CU, concave down, CD. If a graph is curving like a U shape, see, it kind of looks like a U shape there. That's called concave up. If the graph is curving like an upside down U, we're going to call that concave down. There's a very easy way to remember. U is for up. I mean, the word U, or the letter U, concave up, U shape. Up, U is obviously U shape. So upside down U is considered concave down. Okay. Now, what are they trying to show me? They draw some tangent lines here. Okay. One way you can categorize concave up is that if you draw the tangent line, it looks like the tangent line lies below the curve. Okay. For concave down, it looks like the tangent line is above the curve. Okay, so concave up, concave down. Right? Think of it as U shape, upside down U shape. Right, so how can we tell if a graph is concave up, concave down? Okay, so on the bottom of the same page, 644, and if you want to put this on your cheat sheet, you may, or shorten it. Okay, concave up. Okay, they give me 2 marks here. F double prime is what we say. It looks like prime prime. That's called the second derivative. See, what is the second derivative? It's the derivative of the derivative. Okay? Now, when you take a derivative, you come back with a function again. So since you come back with a function, you can take another derivative. Okay, now, we won't prove it in our course. If you were to take a formal calculus course, they might prove it for you, but we'll just state it. Okay, concave up, the second derivative is greater than 0 or positive. Okay, so concave up, F double prime greater than 0. Concave down, F double prime, second derivative is less than 0 on an interval. Okay, if you want to summarize all this, I mean, everything they say is correct. They're trying to be more precise. You just want to quick and dirty, concave up, F double prime greater than 0. Concave down, F double prime less than 0. In fact, if you want to abbreviate even more, just put CU, F double prime greater than 0. CD, F double prime less than 0. Okay, so second derivative. What is the second derivative? The derivative of the derivative. Okay, now, so it's there. It's on bottom of 644. Let me show you this graph here. here's some function, looks like it's x cubed minus whatever. It doesn't really matter, but this is what it looks like. They did that in a graph and calc, it looks like. Okay, I would say the graph is concave down, right, up until maybe somewhere around here. Then after that, it switches to being U-shaped, concave up. Okay, so concave down, concave up. Okay. Point of inflection or inflection point. Point of inflection. Okay. A point is called a point of inflection or inflection point if the curve is concave up on one side of the point and concave down on the other side. Okay. So the graph switches from concave down to concave up, or the other way around, from concave up to concave down. The second derivative at this point will either be 0 or undefined. In practical terms, for all the problems that we're going to do, it's pretty much always going to be second derivative is equal to 0. Okay, so we will set the second derivative equal to 0 and then determine if we have a point of inflection or not. And I'll show you how to do that. So a lot of the analysis for the second derivative is similar to the analysis for the first derivative. You just have a different function. Okay, so we have our original function f. We're going to do f prime and then f double prime, second derivative. What is the second derivative? It's just the derivative of the derivative. Okay, so the first derivative from last time controls increasing or decreasing functions. When's the graph going up? When's the graph going down? The second derivative, we now know, controls concavity, concave up, concave down, and points of inflection. So you know how we set the first derivative equal to 0 to find max and min? We did that in the quiz. We're also going to set the second derivative equal to 0 to find possible inflection points. And I'll show you how to do that. So some other things I have here. Okay, so concave up, concave down, concave up. Okay, we're going to make a sign chart. I'll show you how to do that. But basically, the sign chart is very similar to the sign chart last time. It's just with the second derivative. Okay, I'm on page 646. Okay, now what are they trying to show me here? They're not trying to show me maximum and minimum points. We did that last time. They're trying to show that these 2 points are inflection points. Okay, so right here, that looks like it's U-shaped, concave up. Okay. Then for a little time, it looks like it's kind of upside down U-shaped, concave down. And then the rest of the time, it switches to being concave up. So what they're trying to say is that these 2 points are inflection points or points of inflection. That's where the graph switches from concave up to concave down, or from concave down to concave up. Notice they're different than maximum and minimum points. They have nothing to do with maximum minimum. Okay, that doesn't look like a maximum or minimum. That doesn't look like a maximum or minimum. Okay, it's where the graph switches. Okay, from here's concave up, concave down. So by definition, this is an inflection point. And concave down, concave up. So this is also an inflection point. Okay. Then on page 647, here's a function that's always increasing, but they're saying this is an inflection point. Okay. We won't get into it that much because we don't have the time, but at an inflection point, you have what's sometimes called a point of diminishing return. So even though it's increasing by less and less. Okay. So this is a point where you have a maximum slope. Okay. The slope is the largest at the inflection point. So here the slope gets steeper, gets bigger, and then it starts to decrease. So this looks like an inflection point. Okay. On this particular graph, it looks like it's concave down everywhere. So there's no inflection point. That looks like a maximum. Okay, but this, I would say, is always concave down. And by the way, if the graph is a straight line, we don't talk about concavity. This is not concave up or concave down. It's just a straight line. So concave up and concave down are only for curves, for curved objects. Okay. All right. So now, analyze this a little bit more. Okay. So that looks like an inflection point. Maybe that looks like an inflection point. Let's see. Concave down, concave up, concave down, concave up. So I have an inflection point somewhere maybe here, and it looks like the origin, and also somewhere over here. All right, so now for the homework problem, we're going to tie last time's stuff with this time. We're going to do maxima and minima. Those are the plural you might recall for maximum and minimum. One maximum, two maxima, one minimum, two minima. We'll find all that out and also inflection points. Okay, so there's a lot more to the graphs. So here we go. So the assignment was 15 to 22. Again, I don't know if yours matches mine. Okay, I'll just go with it. And if not, we're just learning stuff. Okay, so find relative maxima, minimum, points of inflection, and sketch the graphs. Okay. So here we go. So 10.2, this is my problem 16, x cubed minus x squared. All right, so we're going to do everything we did last time, but more. Okay, so remember how last time we took the first derivative? And by the way, yeah, now we're going to say first derivative, second derivative. Okay, before we just said derivative. But now you can take the second derivative. We say y double prime, prime, prime. What's y double prime? It's the derivative of the derivative. Okay, so let me take the first derivative, 3x squared minus 2x. Pretty straightforward. What is the second derivative? 6x minus 2. All right. Now, the first part is just like last time. Find maximum and minimum. Set y prime equal to 0. So 3x squared minus 2x equals 0. Factor out an x. 3x minus 2 equals 0. So that means either this is 0 or this is 0. X equals 0 or 3x minus 2 equals 0. X equals 0 is done. This one, add 2. 3x equals 2. So x equals 2/3. Okay, so our critical numbers are 0 and 2/3. Okay, because when I plug in 0, I get 0 for the first derivative. And when I plug in 2/3, I also get 0. You can tell if you plug in 2/3 here and 2/3 here. 3 times 2/3, the 3's would cancel out, giving me 2. 2 minus 2 is 0, and 0 times that is 0. Okay, so these are the critical numbers. Change them to points. I have to plug back into the original. 0 is nice, but 2/3 is not nice. Okay, plug in 0. 0 cubed is 0. 0 squared is 0. 0 minus 0 is 0. 0, 0. 2/3, however, is not nice. It looks like you come out with -4/27. Okay, if you plug in 2/3, 2/3 cubed minus 2/3 squared. Okay, so 2/3 cubed minus 2/3 squared. 2/3 cubed, 2 cubed is 8. 3 cubed is 27. 2/3 squared is 4/9. So I have 8/27 minus 4/9. Common denominator is 27. So multiply by 3, multiply by 3. So that gives me 8 minus 12, or -4/27. Okay, so my ordered pairs are 0, 0, and 2/3 -4/27. This is so far just the same as last time, no different. I make my sign chart. So right now, nothing new from last time. Y prime equals x times 3x minus 2. Okay, so what do I put on my number line? I put down 0 and 2/3. Not very convenient. Here's my y prime. I will now say first derivative. Okay, pick something here, here, and here. So what's over here? -1. Okay, something between 0 and 2/3. I picked 1/3, right? And then bigger than 2/3, about 1. Okay, and I plug into y prime. Okay, plug in -1. -1 is negative. 3 times -1, -3, minus 2 is negative. Negative times a negative is positive. So positive in this region. 1/3. 1/3, positive. 3 times 1/3. 3 times 1/3 is 1. 3's cancel out. 1 minus 2, negative. Okay, so I have a positive times a negative, that's a negative. So this region, negative. And 1. 1 is positive. 3 times 1, 3, minus 2, positive. Positive times positive, positive, increasing. Okay, so I can give intervals of increase and decrease. Okay, so where's the function increasing? From -infinity to 0. So f is increasing, that's an arrow up, parenthesis, -infinity, 0. U stands for union, U-N-I-O-N, if you can't read that. Union means you're joining more than one set. Union, 2/3 to infinity. That's where the function's increasing. Okay, so -infinity to 0, -infinity all the way out to the left, positive infinity all the way out to the right. So from -infinity to 0, union 2/3 to infinity, that's where the function's increasing. The function's decreasing only between 0 and 2/3. Now, if the roller coaster, the ride, goes up, then goes down, what does that mean about right here? Maximum. So 0, 0 is a relative maximum. Now, at 2/3, okay, you're hiking. You hike down, then you hike up. So you reach the minimum. So 2/3, comma, -4/27 is a relative minimum. Okay, so far, this is exactly like last time. Okay, so I would graph 0, 0, a maximum, 2/3, comma, -4/27, a minimum. I know the graph increases, so increasing, decreasing, increasing. Okay, so that would have been last time stuff. Okay, but now comes the new stuff, the second derivative analysis, which is pretty much the same game as the first derivative analysis. And that will give me inflection points. Right, so all of this was old stuff. Now the new stuff, very similar. Set y double prime equal to 0. Y double prime is the derivative of the derivative. We call it the second derivative. The second derivative equal to 0. So where was my y double prime? Right here. 6x minus 2. Set it equal to 0. It's going to be a fraction. Add 2. Divide 6. So x is 2/6, which is 1/3. Plug back in. Not nice. So 1/3 cubed minus 1/3 squared. Okay, 1/3 cubed is 1/27. 1/3 squared is 1/9. Common denominator is 27, so multiply by 3/3. Gives me 1 minus 3, or -2. So I have 1/3, comma, -2/27. Okay. So where's that going to be on my graph? Well, 1/3 is between 0 and 2/3. And -4/27, 0, -2/27, which is right in the middle, very conveniently. Now I do the same sign chart. Okay, so the exact same stuff you did last time, setting it equal to 0, sign chart, you do the exact same thing, only it's for the second derivative. And it controls concavity, concave up or concave down. Okay, so y double prime, okay, what is y double prime? Second derivative. Second derivative means derivative of the derivative. Okay, so what's the derivative of this? This. And take a look, 3x squared minus 2x, that's a function in itself. So it obeys all the other properties of functions, which means you can take its derivative. So I am taking the derivative of the derivative, i.e. second derivative. Y double prime is what we'll say. Okay, so I draw my number line, just like I drew the number line here, but I don't have to lay down the same number of points. Here you lay down 2. Looks like here I'm only laying down 1 value because there's only 1 value, which makes the second derivative 0. That was 1/3. Right? So y double prime was this. You can tell when you plug in 1/3, 6 times 1/3 is 2. 2 minus 2 is 0. Okay, so I put 1/3. Only at 1/3 I get 0. So nowhere else do I get 0. So it's either going to be a positive or negative. So I plug in something over here, something over here. Okay, so I plug in 0 to the second derivative, not the first derivative, the second derivative. 6 times 0 is 0. 0 minus 2, negative 2, it's negative. Okay. Then something over here, 1. 6 times 1 is 6. 6 minus 2, positive. All right, so I'll show that to you again in the book. Page 644 at the bottom here. Concave up, f double prime greater than 0. Concave down, f double prime less than 0. So here we go. I'm doing the second derivative. Negative means concave down. Positive means concave up. Put that on your next cheat sheet for the next test. Okay, intervals of concavity. So function f is concave down, abbreviation CD, where? From negative infinity to 1/3. The function f is concave up, CU, from 1/3 to infinity. Okay. Do I have an inflection point? Yes, I do. There was a change in the concavity, and let me just show that to you one more time. Page what? 645, if you need this. Point of inflection. A point of inflection, okay, the curve is concave up on one side of the point and concave down on the other side. That means it switches concavity, either from concave up to concave down or the other way around. So was there a change in the concavity? Yes, there was. Concave down, concave up. So 1/3 comma negative 2 over 27 is indeed an inflection point. So I've got the graph completely analyzed. So here we go. We already got increasing, decreasing, increasing, but now what about the way it's curving? Up until 1/3, from negative infinity to 1/3, it's concave down. So it's upside down U shape. See how it's upside down U? Up until the inflection point, which is right here. I know, maybe I should draw an arrow here. Here's the inflection point. And then the rest of the time, it's concave up. It's U shape. So notice the rest of the time, it's U shape. Okay, so that's a complete analysis of this graph. Yeah, you can see there's a lot of stuff going on. No question about it.
Professor?
Yes, question.
What is the abbreviation are you using for points of inflection?
Inflection IP for inflection point.
IP?
Yeah, inflection
Thank you.
point. You're welcome.
I have a question too.
Yeah, and by the way, quickly, yeah, I know you have a question. I think last time I put HIP, horizontal inflection point, or horizontal point of inflection, something like that. Inflection point, yeah. Go ahead. Question?
On the first part of the exercise, so yeah, so on the y derivative, go down closer to where you did the chart. Yeah, so on the top of the y derivative, what's next to 8 there in
8
that
minus
fraction?
12, right here?
Oh, yeah.
8 minus 12? Yeah.
Yeah, that was my question. Thank you.
Okay. That's 4 times 3 is 12. Okay, so that was just one problem. Okay, so that's what I said. We, quote unquote, only have 8 problems, but I made it 8 because they're long. Some of them can be quite long. I mean, what is it? It's already 6:15 and we've only done one problem. Okay, So let me see if I can do 2 more, hopefully. Okay, 18, or I should more accurately say my 18, I'm not sure if it's yours. X cubed minus 3x squared plus 6. Okay, so with these problems, you start off with 2 derivatives. So what's the derivative of this? 3x squared minus 6x. And then y double prime, 6x minus 6. Okay, so at least this time, I don't think I have any fractions, which is nice. Okay, so start off by taking 2 derivatives. Okay, so there's y prime, y double prime. Okay, the first part of the problem is just like last time, set the derivative equal to 0. 3x squared minus 6x equals 0. Factorize. 3x times x minus 2 equals 0. Okay, so what number makes this 0? 0. What number makes this 0? 2. So my critical numbers are x equals 0 and x equals 2. Now I need to find the y values. So plug back into the original for the y values. So put 0. I like 0, right? 0 cubed is 0. 0 squared is 0. 3 times 0 is 0. So 0 minus 0 plus 6 is 6. Okay, so 0 minus 0 plus 6, that's a 6 there. Equals 6. 2 is a little bit harder. 2 cubed, 8. Put a 2 there. 2 squared is 4. 3 times 4 is 12. So minus 12 plus 6 comes out to be 2. So I have 0, 6 and 2, 2. All right, then I do my sign chart again. So y prime equals 3x times x minus 2. So sign chart, lay down on the sign chart the numbers where you got 0 for the derivative. That was 0 and 2. 0 and 2. Again, I have 3 regions. By the way, I'm not going to say you're always going to have 3 regions. It seems like that happens a lot, but don't say that's always going to happen. Just whatever it is whatever it is. Okay, so pick something here, here, and here. So to the left of 0, negative 1. In the middle, 1. Over here, 3. Plug into the derivative. Okay, negative 1. Again, I only want the sign. Okay, it saves a lot of work when you don't have to find the exact value. You just want the sign. 3 times negative 1, negative. Yes, it's negative 3, but I don't care about that. I just want to know the sign. Negative 1 minus 2, negative. Right? Save a lot of work when you don't need the exact value. What's a negative times a negative? Positive. So I put a plus here. Do the same thing for 1. Do the same thing for 3. Okay, 1. 3 times 1, positive. 1 minus 2, negative. Positive times a negative, negative. So I put a little minus sign there. And 3. 3 times 3, positive. 3 minus 2, that's 2 there. 3 minus 2, positive. Positive times positive, positive. Right? So from last time, first derivative, before I just said derivative, now we say first derivative, positive, increasing. Negative, decreasing. Positive, increasing. So once again, if you're driving, drive up a hill, right? Up, then you go down. You reach the maximum. So when x is 0, 0, 6, I guess it was, that's going to be a relative maximum. REL stands for relative maximum. How about 2? Okay, so you walk down, and then you walk back up. You reach the minimum. You bottomed out. So 2, 2 is a relative minimum. All right, so as far as increasing and decreasing is concerned, we are done. Okay. 0, 6 maximum, 2, 2 minimum. Up, down, up. But now we want to know how does it curve, which way does it curve. Okay. So now we do the new stuff, the second derivative analysis. So I said y double prime equal to 0. So where was my double prime again? 6x minus 6. 6x minus 6 equals 0. That's pretty easy. X equals 1. Right? Add 6, divide by 6. Okay, plug in 1 back to the original. 1 cubed is 1. 1 squared is 1. So it's going to be 1 minus 3 plus 6. 1 minus 3 plus 6 comes out to be 4. So 1 comma 4. Do the same thing. Y double prime, 6x minus 6. On my number line, I lay down only the number 1. What's so special about 1? Well, when I plug in 1, I get 0. Not for the first derivative, but for the second derivative, y double prime. And that's the only value for which I get the result to be 0. So if I plug in any other number, I do not get 0, which means it's either going to be positive or negative. So I have to determine, is it positive or is it negative? So I picked something over here and something over here. And you don't really have to make much of a sign chart. It's pretty easy to tell when you have this. So I plug in 0, right? 0 is over here. 6 times 0, 0. 0 minus 6, negative. Okay. Then I plug in 2. 6 times 2, 12. 12 minus 6 is 6, positive. All right, so negative second derivative, concave down. Positive second derivative, concave up, CU, CD. Upside down U shape, U shape. All right, so I can have intervals of concavity, just like I have intervals of increase and decrease. Maybe I didn't talk about this at this time. So let me go back and talk about intervals of increase. So F is increasing from negative infinity to 0, union, U for union, 2 to infinity, and F is decreasing only between 0 and 2. Okay, and we have 0 comma 6 as a relative maximum, 2, 2 is a relative minimum, REL, MAX, or MIN. All right, I do have an inflection point. There's a change in concavity. The graph switches from concave down to concave up, upside down U shape to U shape. Right, so the function's concave down from negative infinity to 1. Concave down from negative infinity to 1. And then concave up the rest of the time from 1 to infinity. And yes, I do have an inflection point at 1, 4. So here's the entire graph. Okay. Increasing, maximum, decreasing, minimum, increasing. But it's concave down from negative infinity up to 1. So here's 1. So if I can temporarily cover this. All of this region here, upside down U shape, right? Upside down U shape. And then from 1 to infinity, the rest of the time, U shape, like so. And so there's my entire graph. Okay. All right, so that's that. Okay, so I was going to show you one more, and that's it, and then I'll let you ask questions. I know some of you might have a question inside the chat, but I can't see it right now. But let's see how it goes. Okay. So my problem 22, they were actually very kind. They gave us the first and second derivatives already. So that was a little bit too kind. So anyway, x to the 5th minus 5x to the 4th. Okay. F prime is this. Well, they probably already factored it, because the first derivative would be what? 5x to the 4th minus 20x cubed. I know what I'll do. Why don't I just, well, they gave that to us. But if I work it out, that's 5x to the 4th minus 20x cubed. And then if you factor it, it comes out to be this, right? And likewise, if I take the second derivative, yeah, I can do that. That's what, 20x cubed minus 60x squared. And if you factor, it comes out to be this. So there we go. Okay, set the first derivative equal to 0. 5x cubed times x minus 4, set it equal to 0. That's pretty easy. What makes this expression, 5x cubed, 0, 0? What makes this 0? 4. Now, 0 is nice, but 4 is probably not nice at all. Okay, what do you get when you plug in 0? 0. 0 to the 5th power is 0. 0 to the 4th power is 0. 5 times 0 is 0. 0 minus 0 is 0. 0, 0. 4, however, is really not nice. Plug in 4 here and 4 here. 4 to the 5th power minus 5 times 4 to the 4th power. 4 to the 5th minus 5 times 4 to the 4th. You could punch it in a calculator. Okay, it comes out to be negative 256. If you want to know what I did here, I did a little algebra trick, even though it's all arithmetic. Rather than punching in a calculator, I decided to factor out 4 to the 4th. Okay, that has a 4 to the 4th. That has a 4 to the 4th. So I take out 4 to the 4th. I have 4 minus 5, which is negative 1. And then 4 to the 4th power is 256. So 4 comma negative 256. If you don't understand what I did over here, just punch it in your calculator. 4 comma negative 256. Okay. So what do I lay down on my number line? 0 and 4. 0, 4. What's so special about 0 and 4? When I plug them into the first derivative, I get 0. Plug in 0 here and here, that becomes 0. Plug in 4 here and here, well, this is 0, so 0 times that is 0. That means everywhere else, it isn't going to be 0. So not 0 means either positive or negative. So determine the sign. Is it positive or is it negative? So pick something over here, negative 1. Something in the middle, 1. You can pick 2 or 3. Something over here, 5. You can pick 6. You can pick 7. You can pick 80. But, you know, might as well make it nice and easy. Okay, and I plug in here, negative 1. 5 times negative 1 cubed. Negative 1 cubed is a negative, times 5 will be negative. Negative 1 minus 4, negative. Negative times a negative, positive. Plug in 1. 5 times 1 cubed, positive. 1 minus 4, negative. Positive times a negative is negative. So this region, put a minus sign. And then we said 5. Put a 5 here. You can see we're very happy we don't have to find the exact value. We don't care about the exact value. We just need the sign. 5 times 5 cubed, positive. 5 minus 4 is 1, positive. Positive times positive, positive. Okay, so once again, increasing, decreasing, increasing. So that means maximum, minimum. Okay, so the function f is increasing from negative infinity to 0, union 4 to infinity. F is decreasing between 0 and 4. So 0, 0 is a relative max. That's REL if you can't read that. Relative max, relative maximum, but for short, REL MAX. And 4 comma negative 256 is a relative minimum. And that seems to make sense. I mean, this is so low. Negative 256 is way down there, right? So it kind of makes sense that it would be a minimum. Okay, so for the first derivative analysis, just like last Thursday, up, down, up. 0, 0 maximum, 4 comma negative 256 minimum. But now I have to do the second derivative analysis. How does it twist and turn. Okay. So set f double prime equal to 0. So my second derivative came out to be this. So I set that equal to 0. 20x squared times x minus 3 equals 0. Again, that's pretty easy. What makes this thing 0? 0. And what makes this 0? 3. X equals 0 and 3. 0, 0, well, we already got that. We got 0, 0 before. 3, however, is not nice. Okay, it comes out to be negative 162. Okay, so if I put 3 here and here, 3 to the 5th power minus 5 times 3 to the 4th power. 3 to the 5th power minus 5 times 3 to the 4th power. You can punch it in my calculator, but I did a little algebra trick again. There's a common factor of 3 to the 4th. That has 3 to the 4th. That's 3 to the 5th. That means it has 3 to the 4th. That has 3 to the 4th. So I take out the 3 to the 4th. I have left 3 minus 5. Okay, and I know that happens to be 81 times negative 2, negative 162. Okay, so I just decided to show you that. But if you don't like that, just punch it in your calculator. So 3 comma negative 162. And we know where 0, 0 is. Now, where do I put 3 negative 162? Well, that's between 0 and 4, not exactly in the middle. And that's negative 256, that's 0. Negative 162, okay, it's a little bit higher. Not exactly in the middle, but it's here somewhere. All right, so now I do my sign chart for f double prime. So f double prime was this. I lay down 0 and 3. So 0 and 3. Okay. Why? What do you get when you plug in 0? 0. What do you get when you plug in 3? 0. And those are the only values. That's the reason why I solved this. When I solved this, I only got 0 and 3. So nowhere else will I get 0 for second derivative. So everywhere else, it's either positive or negative. So pick something here, something here, something here. And notice something that makes it nice. What do you know about 20x squared? As long as I don't plug in 0. This expression is always positive. So plus, plus, plus. So these 3 pluses represent the 20x squared, right? No matter what, it's going to be positive. So I only have to worry about x minus 3. Okay, negative 1. Negative 1 minus 3, negative. Positive times negative, negative. 1, we already know that's positive. 1 minus 3, negative. Positive times negative, negative. So negative, negative. And 4, I already know that's positive. 4 minus 3, positive. Positive times positive, positive. So negative, negative, positive. Okay. Second derivative negative, concave down. Concave down. Second derivative positive, concave up. Go ahead and build your cheat sheet for the next test. Put that down on your next cheat sheet. Okay, so now here's something different. First, let me put the intervals of concavity. So the function is concave down from negative infinity to 0, union 0 to 3. Concave up the rest of the time, 3 to infinity. Now, take a look at x equals 0. Does this qualify as an inflection point? Take a look, CD, CD. So by definition, this is not an inflection point, even though the second derivative was equal to 0. Okay? So second derivative equal to 0 does not guarantee an inflection point. You have to have a change in concavity. So concave up on one side, concave down on the other side. That doesn't happen here. Okay? Even though the second derivative is 0, concave down here, concave down here. So by definition, no inflection point. I do have an inflection point at 3 comma negative 162. Why? The change in concavity. Concave down on this side, concave up on this side. Okay, so I'll be done. Okay, so now we have the entire graph. We already know increasing, decreasing, increasing. I got that from the first derivative. a relative maximum at 0, 0, relative minimum at 4, comma, negative 256. Now for the second derivative, how does it curve? So first concave down, negative infinity to 0, 0 to 3. So upside down U shape, upside down U shape. And then the rest of the time it switches to being U shape from 3 to infinity. So it swings like that the rest of the time. And so there's my entire graph. All right, folks. So that was it for what I was going to lecture on. And I will let you ask questions if you have any. So let me stop the share, check the chat. Got that? Okay, I think we're caught up. Thank you again, Jonathan. Sure. Okay, so it's only 6:35. It's up to you. You can ask me stuff. I can do another problem, or I can do a problem from the previous section. But if you don't have anything, then we're done for the day. And yeah, for next time's quiz, anticipate something like what we did today. So you might have to do not only the increasing, decreasing, maximum, and minimum, but also the concave up, concave down, and points of inflection, stuff like that for the quiz on Thursday. Okay. All right. So you can unmute yourselves and ask a question, or you can put it in the chat. But otherwise, we're done. So does anybody want to ask me anything, please?
Professor Hom,
Yes.
can you do 10.1 number 7?
10.1 number 7.
No. Sorry. 10.1 number 9.
10.1 number 9. Okay.
Yes.
And are there any other questions? Because once I switch over, I can't see the chat anymore. So anybody else want to ask a question? You can either unmute yourselves or put it in the chat.
Thank you.
Okay, thank you. Then I'll switch over. 10.1 number 9. And again, maybe it's better for me to ask you what it is again, because mine may not match yours. So let me go back to sharing the screen. If I can get over there. Okay, so 10.1 number 9. And could you read me what that is?
Number 9 is y. Okay. Number 9 is y equal to 2x to the power of 5 plus 5x4 minus 11.
Minus 11?
Yes.
Like that?
Yes.
Okay. And just out of curiosity, let me compare it with my book.
I think it's the same.
10.1. It was the same for last time, right? Yes. Okay. All right. So y prime is 10x to the 4th plus 20x cubed. Is that right? Which factors into 10x cubed, parentheses, what?
X
plus
plus
2?
2.
Right. Okay, set it equal to 0. So I get
So
x equals
X
0.
equals to 0. X
and
equals to
negative
minus
2.
2.
Is that right?
Yep.
Okay, and what are the y coordinates? 0 is easy, 0, 0, negative 11.
So when you do the 0, you have to base on the original.
The original function to find the y value, yes. Find the y coordinate.
Ah.
0 is nice. Negative 2 is not going to be nice. So what do I get when I plug in negative 2? I don't know. Looks harder. 2 times negative 2 to the 5th power plus 5 times negative 2 to the 4th power minus 11. Oh boy. So that's 2 times negative 32 plus 5 times 16 minus 11. Negative 64 plus 80 minus 11, which I think comes out to be 5. So negative 2 comma 5, I think. Did I do that right?
I didn't do that one. That's why I'm confused when you plug in the 0 and minus 2, which equation that you should do.
Okay.
So I
Well,
thought
you
it's
want,
from the derivative. So it is not from derivative.
so you plug in 0 to the original to find the y coordinate. And this
I
kind of gives
see.
it away. It says y. Right? So how do I
Mhm.
find y? I plug in here, not here.
Mm-hmm.
So
Okay.
0 gives me negative 11. And I think negative 2 gives me 5. Well, I'm going to go with it. And tell you what, if somebody tell me that I'm wrong, okay, so otherwise I'm going with negative 2, 5. Okay, so y prime, where was it again? 10x cubed, x plus 2. 10x cubed, x plus 2. Okay, so I lay down a negative 2 and a 0. Is that right?
Yeah.
Okay, so I picked something over here, and over here. So negative 3 and negative 1 and 1. Is that right?
Yeah.
Okay, and change colors here. Okay, plug in negative 3. Negative 3 cubed is a negative, times 10 is a negative. Negative 3 plus 2 is negative 1, that's a negative. And a negative times a negative will give me a positive. So again, this is positive. Negative 1. Negative 1 cubed is negative times that, so negative. Negative 1 plus 2 is 1, positive. Negative times a positive. Negative. 1, positive, positive, positive. Oops, forgot to put the negative. Okay, so increasing, decreasing, increasing. So maximum, minimum. So F is increasing from negative infinity to negative 2, union 0 to infinity. The function is decreasing only between negative 2 and 0. And I have a relative max here and a relative min there. Okay, so negative 2 comma 5 is a relative max. 0 comma, what was it, negative 11 is a relative min. And that pretty much does it. So I can do a quick graph for that. Quickie graph, relative positions. Negative 2, 5 is sort of like that. Negative 2, 5, and I know that's a relative maximum. And 0 comma negative 11, I'll just put it over here somewhere, is a relative minimum. The graph goes up to the maximum, down to the minimum, back up to the maximum, so something like that. And yes, it looks like there's probably going to be an inflection point somewhere here. I guess it would be at negative 1, maybe. Okay.
Professor, how do you see the union says 0 to infinity?
Union? Yeah, so you have more than one region where I have a plus. This one, this one. So to join them, you put a U for union. Okay, from negative infinity to negative 2, increasing. But that's not the only region, 0 to infinity also. So when there's more than one region, you put a U for union.
Oh, okay. Thank you.
You're welcome. Anything else about this particular problem? Anybody? Yeah, if you have a question about this one, please let me know now. Otherwise, I'll stop the share to check back the chat.
I do.
Yes, go ahead.
So after you do the chart, the science chart, that's how you find when it's increasing or decreasing.
Yes.
So after finding plus, minus, and plus in the charge, that's how you figure out the arrows in there where you're
Correct.
pointing.
Yes.
Can you
This is my
explain that again?
abbreviation, right. Yeah, this is my abbreviation for increasing function. And that's my abbreviation for decreasing function. You won't find that in a book. That's my own thing.
Yeah, so it's plus there, it means it's going up,
Correct.
right? If
Increasing.
-3 is plus, then it means it's increasing.
Correct. This whole region, everything from negative infinity up to -2, the graph is going up. So it's increasing up until I reach -2, and then it starts to drop. And then after x equals 0, it starts going back up again. Is that right?
Thank you.
You're welcome. Okay, anything else about this particular question, please?
Yeah, can you plug in the -3 in the equation to show where it turns into a positive?
Okay, where does it turn into a positive? Okay, so you're talking about right over here? Yeah, so I plug in -3. I don't need its exact value. That's too difficult. I just need the sign. So -3 cubed is a negative number. It's -3 times -3 times -3.
So
It's a negative, and then
right?
times 10 is a negative. So that's indicated by that minus sign.
I see, okay.
And then -3 plus 2 is also negative. So that saves me the trouble from finding the exact value. I don't need the exact value. I just need the sign. The sign of the whole thing is positive, because when I plug in -3 there, this whole thing is negative. I know that. And when I plug in -3 there, this is negative. So I'll have a negative times a negative, which is positive.
Right, so if we were to work that out, 10 times -3 cubed, it would end up as a negative number, for example.
Exactly.
We just
It's a
need the negative number for that.
Yeah. It happens to be negative 270, I think, or something. You know, we don't care about that. We just want to know the sign. Saves us a lot of work.
Yes, and then you plug it in the second x plus 2, same thing.
-3 goes here also. -3 plus 2 is -1, but the key thing is that it's negative.
Copy, thank you.
Okay, you're welcome. Okay, so let me stop the share. Anybody else? Let me check the chat. Okay, 10.1, number 19 was asked for. Y equals x to the 2/3.
Can you do also 10.1, 10.120?
Okay, I'm not sure how much time I have left for that, so we may not be able to, but let's see. Y equals x to the 2/3. Okay. Is that your number 19? X to the 2/3?
Yes.
That matches, okay. So actually this one might be pretty fast, so I might be able to have time for another one. Okay, so y prime is 2/3 x to the -1/3, which is 2/3 cube root of x. Okay, now x equals 0 is a critical number because I'm not even allowed to plug in 0 here. Okay, so here's one instance where we have to set the derivative to be undefined. Okay, by the way, this cannot equal 0. If I set it equal to 0, that's impossible. Because one is a fraction equal to 0. A fraction is equal to 0 when the numerator is 0, but the numerator is already 2, so it can't happen. Okay. X equals 0 is a critical number because you can't divide by 0. So I put down 0, 2/3 cube root of x. You can tell that the sign is determined by just what you plug in. Okay, it's pretty straightforward. If I plug in a negative number, this is negative, right? You can take the cube root of a negative. It'll be negative. All of these are positive. So this side is negative. This side is positive. So decreasing, increasing, and that's all it does. And what do you get when you plug in 0, 0? Okay, so 0, 0 is a minimum. Yeah, so this one was actually pretty fast. All this graph does is it goes down to 0, and then it goes up. So however it looks like, okay. I don't know that it exactly looks like that, but it might be something weird like that.
So it's not curved, it's a straight line.
Oh, no, it is curved. Sorry, I should have made it more
Okay.
curvy. So I do have a minimum at 0, 0, and that's it. And the function's decreasing from negative infinity to 0, and the function's increasing from 0 to infinity. So I do have a minimum at the origin, it looks like.
So you were saying that this derivative is equals to 0. The total of derivative is, the result is 0.
No, if I try to set it equal to 0, the normal protocol is to set it equal to 0, but that's impossible. Okay. X equals 0 is a critical number because x equals 0 is undefined for the derivative. Okay. So technically a critical number, you set the derivative equal to 0 and undefined. And I alluded and said most of the time you don't have to worry about undefined, but this is one instance where you have to worry about undefined. It was most of the time you set the derivative equal to 0.
So, but we don't have to write undefined. We just say critical point.
You don't have to just say it's a critical number. Yeah.
Okay.
That's good enough.
Professor,
Yes.
in the sign chart, how did you get the minus, the first minus?
Okay, so I plug in -1.
Uh-huh.
Okay. The cube root of -1 is a negative. It's -1.
Uh-huh.
That's negative. 2 and 3 are already positive. So I have 1 negative.
Thank you.
Positive, positive, negative, so negative.
Mhm.
If I plug in a +1 or +2 or +1,000,000, whatever, everything is positive. So it looks like that. Okay, oh, I didn't write that down. That was problem 19, I believe.
So that's a cube root, you're saying?
Cube root, yes.
Okay.
A -1/3 power means put a cube root in the denominator. So that's a cube.
I thought it's 2, that you put also. Okay, thank you.
2/3 cube root of x. Cube root. Okay. You asked for 20. I'm not sure if we have time for it. Let me start it. Yeah, I think it may come out to be as nice as the other one. So let me try 20. It's still being recorded, by the way, so you can look in the video. I have to turn the paper over. 20, my 20 is what? -x minus 3 to the 2/3?
Yes, that's the same.
Okay, it's probably very similar. So y prime is -2/3 x minus 3 to the -1/3. Yeah, this is very similar because that's the same as last time. It's going to be a cube root on the bottom.
Okay.
So -2/3 cube root of x minus 3. So yeah, the problems are in pairs. 20 and 19 are very similar.
Right.
Okay, again, I cannot set it equal to 0. It
Yes.
can't happen.
Okay.
But I have an undefined value that would be x equals 3. So x equals 3 is a critical number. The rest is similar to the previous one, except that there's a negative there. So it's going to be a
So
swap.
the chart will be 3. All right.
Critical number is 3.
Yeah.
What do you get when you plug in 3, 0? 3, 0. Okay, this time, what happens if I plug in 2?
Yeah.
This will be negative.
Okay.
There's a negative here. So I have a negative times a
Positive.
negative, which is positive.
Okay.
What happens if I plug in 4? Positive, 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 negative.
Negative.
So negative. Increasing, decreasing, that means this is a maximum.
Mm.
Okay, so at 3, 0, it goes up and then it goes down. So up and then down.
Mm.
And that's all the graph does. Okay.
Thank you.
All right, you're welcome. And it looks to me like I think we're just about out of time, folks. So I don't think I have time for anything else. Okay, so next time I'll do another section, section 3, but the quiz will most likely be on stuff that we did here today. Okay. All right, that'll do it for today, folks. So everybody have a good evening, and we'll see you next time.
Thank
Good night,
you.
everybody.
Thank you.
Bye.
Good night.
Good night.